Welcome to Looking Ahead, a podcast on the future of enterprise technology, as seen through the eyes of the tech sector's most influential leaders, hosted by Head CTO Eric Kaplan. This episode features Renen Hallak, CEO of Vast Data. Renen shares his journey of building a data storage system that finally meets today's enterprise needs, including the trade-offs he had to juggle and the legacy mindsets he had to overcome.
Welcome to the latest episode of Looking Ahead. I'm excited because today we have Vast as our guest, and actually I should say Renen, CEO and founder. Welcome to the show today, and glad to have you here. Let's just start out by maybe give us the 2-minute on you, your background, and what Vast does.
Sure. So my background way back when is in computer science. Previous to Vast, I was VP of engineering at a storage company called Extreme.io. Developed an all-flash block device and was acquired very, very early on by EMC at the time. And basically, after I left Extreme.io back in 2015, I started talking to as many customers as I could, as many potential customers as I could, and tried to understand from them what it was that they were missing, not specifically in storage, but in infrastructure in general. And all of them came back to variations of the same thing. They kept telling me that all flash arrays, which were new at the time, were great, that they were a lot denser than the competition, a lot easier to use, easier to manage, no performance tuning, more resilient because there weren't any moving parts. But what all of them were complaining about was the fact that all flash systems were so expensive that they could only put a very small subset of their applications, of their data on them. And the result of that was that they still had many, many tiers of legacy hard drive-based storage underneath, which were hard to manage, complicated to use, expensive to move data around between all of these tiers. And so this was the major pain point that they described. And again, this is back in the beginning of 2016, 4.5 years ago. The more forward-looking customers were already seeing the next wave of applications around analytics and AI and machine learning. And what they were realizing is that it's becoming more and more difficult for them to choose where to place their data, on which tier does it belong, because these new applications required fast access to the entirety of the data set. And so tiering didn't work anymore. And they needed a new type of infrastructure to support these new applications. And that's where we started. That's the problem that we tried to solve in the beginning.
So you're at EMC, you leave, and start talking to these customers. Obviously, there's inhibitors that have caused us to live in this world of tiering storage and managing policies to deal with different types and classes of information, which adds complexity, adds management over time. But there's also real hard technical enablers to cost and resiliency and scalability. Fast forward, what are the key drivers and elements that you, as you looked in the future, you saw starting to become available, that were being developed, that you said, if these things come true, then I think I might be able to knock down some of the barriers that you heard of?
Yeah, so all of those problems that they were describing weren't necessarily new. It was over time that these problems became more and more acute. And when we went back home and with my initial team of architects tried to understand how can we build a storage system that breaks these trade-offs, that is faster than the fastest that exists today, cheaper than the cheapest, more scalable than the most scalable, more resilient than the most resilient, we realized that those trade-offs were there for a reason, that they couldn't be broken. with existing hardware and software underlying technologies. And so we did exactly what you just said. We went out to various vendors like Mellanox, like Intel, and we asked them, what is on your roadmap? What can you tell us about the future that may enable us to build a new architecture and new software on top of your hardware pieces, such that we will be able to get to the point that the customers expect from us. And what they showed us enabled what we built. It was NVMe over Fabrics 2 years before it was ready. It was QLC Flash almost 3 years before it was ready. It was 3D XPoint also 2 years before we were able to get our hands on it. And we assumed that all of these pieces alongside Docker containers and all of these pieces would become available by the time that we developed the software, and we architected around them based on spec sheets, even though we weren't actually able to test with them at the time.
So you meet with the kind of a lot of the, I'd say, industry titans around hardware, I'm sure Mellanox, Intel, et cetera. You see the roadmap that they're developing and you actually don't have physical product in hand. So you have to make a ton of assumptions, I'm sure. And at the same time, you're also challenged with all these legacy historical problems that you want to overcome. Being in storage, I always say, and getting to the point where you have an idea to actually a product that is time tested, has the reliability, is not a 1 or 2 year effort. You guys are 4 years into this. But what were some of the core problems that you looked at and said, you talked about cost and scalability and not tiering, but I think some of the underlying architecture that VAST eventually built, also allowed you to solve many other problems that have been in the legacy storage world for a long time and still aren't resolved by other vendors in the marketplace. So any thoughts on passionate things you were passionate about of I gotta solve this problem and I don't want to inherit it once again in the VAST architecture?
Yeah, so the team came from varied backgrounds in storage and beyond storage, but companies like Extreme.io, where I was, and Caminario, and Isilon, and NetApp, and XIV, and we all came with scars of things we thought we didn't do well enough in previous products, and things we thought were really good and that we should keep. And this new architecture enabled us to solve a lot of those problems in a very simple way, basically eliminate the problem rather than try and solve it. So examples are, at Extreme.io, I can give this example because it's firsthand. It took us about 6 months to build the good path, what we call the happy path. And then it took about 3.5 years to build HA, basically resiliency into the system. And we realized that whenever something bad happens, when a hardware piece fails, or anything that isn't supposed to happens, that's when a lot of code needs to run. And that code is by its nature less tested and has more bugs, and there are more corner cases because by nature, these are failure scenarios. Yeah. And so at VAST, from the first day, we decided not to have to do anything when a bad thing happens. And so everything is built in a way that everything is always in its right place. You don't have any journals that you need to play. You don't have any battery backup units. You don't have any of those things that need to happen when something bad happens. And it took us longer to get the happy path, the good path, working. But once we got it working, there was very little that needed to be done in order to support the failure scenario. And that again goes back to the architecture and to the way that it's built. For example, 3D XPoint, Intel's new NVRAM technology, allows us to land everything on persistent media without having any type of RAM caching. And so when you don't need any battery backups, but more than that, you can now have a lot of nodes that all have access to this very fast persistent media over NVMe over Fabrics. And so none of them actually need to talk to each other in order to serve requests. And so it's not just a resiliency thing, it lends itself to a scale thing. Because when you have 100 nodes and they're all chatting with each other, then that chatter limits your scale. But if they don't talk to each other, you can grow up to 10,000 nodes, to 100,000 nodes, and it's still okay. And so you now have all of this extra redundancy and resiliency because all of these nodes are stateless. All of the state is down in the cross-point layer. And so they can all fail at the same time without losing data. And that's one piece of it. But the other piece of it is half of them can fail at the same time and the other half doesn't even know about it. And so scale and resiliency are no longer at odds with each other. They come together. The conflict between price and performance, again, was very deeply rooted in shared nothing architecture, where every node came with a certain amount of performance and a certain amount of capacity. And that capacity cost more if you wanted it to perform better. Once we disaggregated those two and allowed us to use the lowest cost flash available, we're basically breaking that trade-off. And so breaking all of these trade-offs, what does it mean for the customer? It means that they don't need to think about it anymore. They don't need to choose between high scale or high resilience. They don't need to choose between low cost and high performance. And so the first thing they gain out of it is they don't need to think about storage anymore. It just works. And then the second thing that they realize, usually a few months after they start using the system, is that they can start doing things that they couldn't do before. They can start analyzing not just a small subset of their data, but the entirety of their data set. And they can do it not in a batch process overnight, but in real time. And they can have 100 different teams, whether it's in the financial space where it's quant teams, or in the life science space where it's researchers. They can have all of these teams work on the exact same data set without stepping on each other's toes because of the way we do workload isolation and because each of those teams can get their own nodes that aren't interacting with the other team's nodes.
Yeah. When I look at some of the decisions you made, some of the things that stand out to me is really this disaggregated shared everything architecture, the statelessness around metadata and not having to rebuild and reconstitute that in terms of failure scenarios and just performance and scale as well. And then the container-based architecture. Maybe talk for a second about where you see that container-based architecture going. Do you see, to your earlier point, these new applications want access to the entire data set at times? Do you see a world where VAST and the application start to get closer and closer together?
Mm-hmm. And so, yeah, that's a very interesting question. The way the world tends to work is we have these swings, pendulum swings. For a decade, we have the best cameras and the best phones and the best whatever you would like to see in personal devices, each in its own thing. And then you have a conversion of everything into a single device, a smartphone, but the camera isn't as good as that standalone camera. And the various pieces aren't as good as what they were before. And then you have the pendulum swing in the other direction. I think the same thing is happening now in the data center. We had the very specific pieces of storage, security, networking, compute, databases 2 decades ago. And then in this last decade, we saw a very massive shift towards hyperconverged, putting everything in the same box. And we took it too far because those individual pieces aren't as good as they used to be, although it's a lot simpler to manage. What we think will happen over this next decade is we'll get the best of both of those worlds. And containers are what's going to get us there because you now can have everything in the same box, but you don't need all of those services to be built by the same vendor. And so you can have your software-defined networking in one container and software-defined storage in another container and software-defined database in a third container, and build this microservice architecture where you can choose best of breed for each one of the services that you would like, and it's all in software and it's all containerized. The problem with storage has always been that storage is very stateful. And containers clash with that philosophy. You can't spin up a container or spin it down if the only place you can spin it up and down is on a very specific node that has access to the data. And so NVMe over Fabrics and disaggregation solved that. We now can access all of the information from every single container so long as it's attached to an Ethernet or InfiniBand network. And so disaggregation coupled with this shared everything approach allowed us to take a page out of the public cloud book, out of the hyperscalers book, where they deal with pets versus cattle. Storage is no longer pets. Each node doesn't need to be cared for in the same way.
Sure.
We can now spin them up and spin them down because they're all stateless and none of them have affinity to a specific set of drives.
Have you started to see, I know VAST built a very rich API. Have you started to see clients kind of take advantage of that API, embed it in kind of their workflow and their applications to a degree?
Yes. So we started with standard protocols. We support today NFS, we support S3, we support SMB, and we wrote all of those protocols ourselves. We didn't take any open source because we wanted them to have A, native performance, B, we wanted them to have full advantage of this new architecture. For example, things like failover that were very problematic for SMB before don't exist in our architecture because everyone can see the same shared state. And we also wanted all of these protocols to have access to the same information, whether that be user data or metadata. But what that lends itself to is to expose those internal APIs. And we gain insight not only, there are a few things that can be done that aren't standard as part of those protocols. For example, user metadata can now be searched and indexed, and you can correlate between files and metadata, and you can start doing smart things. If you're, again, giving the life science example, you can tag your files with the sequencer that was used, with the organism that was sequenced, with the symptoms or the different attributes that that organism has. And as you start gaining an understanding of the actual data, you can cross-correlate that with the metadata. And there's no better place to do that than within the storage system, because we have direct access to that metadata sitting on Crosspoint. It's the most efficient way to do it. And so we're exposing those APIs for our customers to take advantage of them. Another example is internal to the system. We have a very sophisticated data reduction mechanism that in fact understands the data in a way. It finds similarity across the entire data set and leverages that similarity in order to reduce data down that was unreducible before. And so that side effect of beginning to understand the data or find similar files across the namespace is another thing that can be exposed in a non-standard way and given to the application with higher level semantics. So we're seeing select customers work with us on defining how they would like to see their next generation storage system. And we're happy to build that for them because we think others will enjoy it as well.
It sounds like you guys have, taken, the path of not wanting to try to introduce a lot of, historical legacy, whether it's from the protocol perspective, the metadata perspective, the hardware perspective. So really built for the future. You obviously made some key bets on technology when you started the company, as we talked about earlier. When you think about the next couple years, what excites you in the industry in terms of other either enablers or technology that you see coming down the pipe that will not only be a benefit to the VAST architecture, but to customers that are adopting the platform?
Yeah, so I think the data center of the future will be very different than the data center of the past. It will not be running VMs and Oracle databases. It will be understanding of data. I think this whole wave that's called AI is at a turning point, and we're going to start seeing more and more applications that aren't just serving data to us human beings, but understanding the data, generating insight from it, and serving us that insight. And as we advance in that direction, I think it'll become clearer and clearer that existing infrastructure was not built with these applications in mind and is not suitable for these applications. And we'll see a bigger and bigger shift into the data center as a computer, as a supercomputer. And in fact, we're seeing a lot of supercomputing ideas tried in this new world. Some of them are a good match, some of them are a very bad match. But thinking of the data center as this supercomputer that can understand data and generate insights for us is, I think, the key driver to what we see in the next few years. And specifically on the hardware space, obviously we're seeing new form factors for SSDs, rulers, things that will make will give us better density and that will make serviceability better. But if I do look into that 3-4 year horizon, I think these new AI chips, whether they're GPUs or IPUs, will be incorporated into the storage system very close to the data, such that these storage systems will not just be able to serve read and write requests, but actually understand the data and give you search-like abilities and insight generation abilities from within the storage system. And that, if I had to think of what are we working on that will be available 3-4 years down the road, that is the thing that excites me.
Yeah, it's kind of your comments earlier. It's, as we've all seen, and you use the analogy of kind of best of breed versus, converged. What's old is new and what's new is old. And these themes keep repeating themselves, with obviously advancements over time, but it's interesting to hear your perspective. I can't thank you enough for joining us today. Great insight, very excited about the VAST platform and the use cases. I think it's very different and unique out there and solves, as we just talked about, a lot of great problems that have plagued the industry for a long time, and not only the industry, but obviously our customers, which are trying to take their businesses in a new direction with new use cases at the end of the day. So great to hear more. You can obviously go to vastdata.com to learn more, or reach out to us at Ahead, and we'd be happy to help educate anyone that's more interested in the platform. So thanks again, Renen. Have a great day.
Thank you.
Thanks for listening to Looking Ahead, featuring Eric Kaplan. Looking Ahead is produced by Ahead, experts in delivering enterprise cloud infrastructure, intelligent operations, and modern applications. We build platforms for digital business. Learn more at thinkahead.com.